Lesson 10.6 probability. Today is day of the dice and the spinner. So we're going to start off first of all talking about what is probability. So probability is the chance of something happening. When we talk about the chance of something happening, that something happening that we want to happen is what we call in math and in probability a favorable outcome. So the outcomes are the list of everything that could possibly happen, and our favorable outcome is what we actually want to happen. So when we talk about probability, we use a capital P, and then in parentheses, we put the event that we want to happen. And then we create a fraction with this. So it is the number of favorable outcomes over the total number of possible outcomes. So for today, we're going to be focusing on the dice and the spinner for our probability lessons. In terms of dice, when we talk about a single event, this means we want one favorable outcome to happen. So we have 6 sides to the dice, which are all labeled 1, 2, 3, 4, 5, and 6. So the probability that we get a 5, we want to look, how many favorable 5 outcomes are there? We only have one side of the dice that has a 5, so that's a 1. Out of, there are 6 sides total. We always do a quick check to make sure that our fraction is reduced and 1/6 is. The next favorable outcome, I'm looking for the probability of 2 or 3. So I would be happy if I roll this and get a 2, and also happy if I roll this and get a 3. That tells me that there are 2 favorable outcomes, but in total, I still only have a total of 6 favorable outcomes. Reducing this fraction, I get 1/3. In the last example, I want the probability of not getting a 1. So I do not want the 1, but I'm happy with the 2, the 3, the 4, the 5, or the 6. So there's 5 outcomes that I would be happy with, or favorable outcomes, compared to the 6 total possible outcomes. So the probability of not getting a 1 is 5 out of 6. One thing that you probably notice here is that the probability of getting a 1 is 1 out of 6. And if we take the probability of not getting a 1 and getting a 1, 5 out of 6 plus 1 out of 6 give us 6, which is 1 whole. So we call these the opposite outcomes. So not getting a 1 and getting a 1, and those opposite outcomes are going to add up to give you 1 whole in terms of their whole probability. When we talk about compound events, you're going to see a comma in between this, or you might even see the word and, which will show you that there are 2 different things here. So our first probability is we want to get the value of a 5. So looking at our options, there's only 1 5 out of 6 spots on the number cube. When we want to get the probability of a 2, there's also only 1 out of 6. So now we have to go ahead and we actually have to multiply these together. The reason that we have to multiply is because in total, there are 36 possible outcomes for one roll of the number cube, the dice, and the second roll of the dice, because I could get a 1 and a 1, a 1 and a 2, a 1 and a 3, and we could list all those potential options out, and that would give us 36 total options. So I multiply my 2 compound event probabilities together. 1 times 1 is 1, and on the bottom, 6 times 6 is 36. 1/36 is reduced. In the next one, I want to get the probability of getting a 2 on my first roll and then an even on my second roll. So when I take my first roll and I get the probability of a 2, I'm looking for 1 out of 6. Remember, I'm multiplying here, and now I want to get an even. Even numbers are 2, 4, and 6. So that would be 3 out of 6. If you remember from multiplying, we can actually reduce on the diagonal here. So the 6 becomes a 2 and the 3 becomes a 1. 1 times 1 is 1, 2 times 6 is 12, and we get 1/12. Had you not realized that, you would have gotten 3 over 36, which would also need to be reduced to 1/12. In the last example, I want to get the probability of rolling a 3, and then on my second spin, rolling a 7. So the probability that I roll a 3 is 1 out of 6. And then the probability I roll a 7 is actually 0 out of 6 because there are no 7s on a number cube. Because this option is not there, when I multiply, you're going to notice I get 0 over 36, which means that there is no chance that I'll be able to roll a 3 on my first roll and then roll a 7 after that. Looking at the next part, we're going to talk about sums of dice. So thinking about if I rolled 2 dice, what would happen if I add their numbers that show up together? So if I have a 1 and a 1, I would get a 2. A 1 and a 2, I would get a 3. A 1 and a 3 would give me a 4, a 5, a 6, and a 7. If I have a 1 and a 2 on this row, I'm going to get a 3, a 4, a 5, 6, 7, and 6 plus 2 is 8. 3 plus 1 is 4, 5, 6, 7, 8, and 9. 4 plus 1 is 5, 6, 7, 8, 9, and 10. 5 plus 1 is 6, 7, 8, 9, 10, 11. And this last one is 7, 8, 9, 10, 11, and 12. Again, from rolling the first die and rolling the second die, I have 6 different options and 6 different options. So my total outcomes is 36 different outcomes. Probability that I get an even, we're going to go ahead and add these up here real quick. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are 18 favorable outcomes out of 36. This reduces to 1/2. In the next one, I'm looking for a probability that's going to be greater than 10. Notice that that only happens down here in this little section. So I only have 3 favorable outcomes out of 36, which will reduce to 1/12 then. So for sums of dice, these are just a list of all your possible outcomes, and then you're just able to figure out your probability using that list. Final piece for today's lesson is using the spinner. So you'll notice here that we have a twister spinner. The twister spinner is divided into 4 sections for the right hand, left foot, and right foot. And then you'll notice that each section is also split up into the different colors. So it looks like my events are going to be based on colors. So when I look at it, there's 4 colors in each section for a total of 16 different colors. It's going to make life a little bit easier. Probability of a red happening, there are 1, 2, 3, 4 reds out of 16 total spots, which gives me a probability of 1/4. Probability of a green or a yellow. So I'm happy with green or yellow. So there's 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 spots out of 16, which tells me that I have a probability of 1/2. For the next part, we're going to be looking at some different colors. So I'm going to erase these spots off of here. We are going to compound events, which means we're going to have 2 different things happening, and we are going to then be multiplying our probabilities. So in terms of getting a yellow, there are 4 yellows out of 16 spots, and we're going to multiply that by the probability of getting a blue, which would be 4 blues out of 16 spots. Again, I can reduce before I multiply. So I'm going to reduce, actually, if I notice, 4 over 16 is 1/4 times 1/4. So that actually makes this way easier, which gives us 1 over 16. I could have also reduced going across diagonally here, which would have allowed me to reduce this a little bit. The next one would be probability of spinning a red and then another red. So on my first spin, the probability that I get a red, there's 4 of those out of 16. And on my second spin, the probability that I get another red is 4 out of 16. Again, I could cross reduce like this, 4, 1, 4 goes into 4 once, 4 goes into 16 4 times. We get 1 over 16 then for our probability here. Taking a look at this next part, fair or unfair. Is the spinner fair or unfair to play a game? In order for something to be fair, you have to have all equal chances of the different outcomes. So taking a look at spinner number 1 right here, would you call this fair or unfair? This one would be unfair because red has a much higher chance of actually happening. Taking a look at spinner number 2 here, fair or unfair? This one would be fair because all the spots have an equal chance of it happening. Spinner number 3, Fair or unfair? It looks like the spinner is equally divided between the three colors, so we would say this is a fair spinner. Finally, in spinner number 4, fair or unfair? In spinner 4, blue has a much larger probability of actually happening. It looks like purple actually has the smallest section, so because of that, this would be considered an unfair spinner.